Section 8.5, our goal is to prove that triangles are similar. We know that there are ways to prove that triangles are congruent. We did proofs for these for first term. We have SSS, which is side, side, side. SAS, which is side, angle, side, angle, ASA, and AAS, which is angle, angle, side. There's also one called HL, which stands for hypotenuse leg. This one only works with right triangles and states that if we have two right triangles and could show that the hypotenuse of each is congruent and one of the legs is congruent, that's enough to say the triangles are congruent. We're going to talk in this unit about ways to prove that triangles are similar. So there are three ways. The first one is AA. So this is angle, angle, similarity. And again, this similar symbol is like the top of a congruent symbol. So angle, angle, similarity. The two triangles are similar if two of their angles are congruent. Now again, I know if two of the angles are congruent, that the third angles have to be congruent by the third angles theorem because all triangles add up to 180. So if all the angles were congruent, that would make the triangles similar, but not necessarily the same size. They're just the same shape. So if I can show that two angles are the same, then the triangles are similar. Let's look at our first triangle. We have 90 degrees and 30 degrees. To find the third angle, I would add these two up. 90 plus 30 is 120 and subtract from 180. So my third angle is 60. Therefore, my 90s are congruent and my 60s are congruent, and these are similar by angle, angle, similarity. The second way to prove that triangles are similar is side, side, side similarity. If your three sides, when put into ratios, your corresponding sides, all reduce to the same scale factor, they all reduce to the same ratio, then your triangles are similar. So I'm going to take, and these triangles were written, so your corresponding parts are in the same position. I'm going to take our 12 and put it over 4. That reduces to 3 over 1. 15 over 5, corresponding parts, reduces to 3 over 1. And 9 over 3 corresponding parts reduces to 3 over 1. Since these all reduce to the same ratio, you can write that proportionality statement and all the parts are true. 12 over 4 is the same as 15 over 5 is the same as 9 over 3. Then the triangles are similar by side, side, side similarity. The third one is called side angle side similarity. Just like side angle side when we did congruent triangles, this needs to be two sides and the angle that's contained between them. So you have to go around in order, side angle side. It must be the angle between the two sides where they meet. So if my angles are congruent and my two pairs of corresponding sides reduce to the same ratio, so 10 to 5 reduces to 2 over 1, 6 to 3 reduces to 2 over 1, then yes, the triangles are congruent by side angle side similarity. So we're going to look at some examples. Are the triangles similar? And if yes, tell why. So you're going to check and either tell me, no, they're not similar. Or if yes, they are, you're either going to state angle, angle similarity, side, side, side similarity, or side, angle, side similarity. Make sure you explain why. In the first picture, we were given all three sides, so I'm really checking for side, side, side similarity. We're going to put corresponding parts into a fraction and a ratio, and we're looking to see if they all reduce to the same ratio. That would be our scale factor. So 8 over 4 reduces to 2 over 1. Looking at the bottom of the triangle, 6 over 3 also reduces to 2 over 1. So far, they appear similar. 10 corresponds with 6. 10 over 6, if I divide them both by 2, reduces to 5 over 3 and is not the same as the other two. So no, these triangles are not similar. Number 2, we have triangles that meet at a vertex. Again, these are vertical angles. We have vertical angles. And that's just a way to remember vertical angles cross. Therefore, I know this angle is congruent to this one. Then my two triangles have two pairs of congruent angles. So yes, these are similar by angle-angle similarity. If there's two pairs of congruent angles, then they're similar by angle-angle similarity. Looking at number 3, I have a pair of angles that are congruent and two pairs of sides. So I'm going to compare my 9 to 3. So 9 over 3 reduces to 3 over 1. 12 over 4 reduces to 3 over 1. And this may appear to be a side angle side. But in order to use side angle side, it must be the angle contained between the sides. This is not the correct angle, and it's not the same angle in the two triangles. So no, these are not similar. Example 4. Again, we're given all sides. We're going to reduce the pairs of corresponding sides to see if we get the same fraction. So 16 corresponds to 4. 16 over 4 reduces to 4 over 1. 20 corresponds to the 5. 20 over 5 also reduces to 4 over 1. 24 corresponds to 6, and if I divide those both by 6, I get 4 over 1. So yes, these are similar by side, side, side similarity. Remember, you need to tell why they're similar, either angle, angle similarity, side, 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 or side, angle, side. Example 5. Yeah, I have two angles and I have a side. Let's go ahead and find our third angle for this first triangle. I know the triangles add up to 180, so 60 plus 80 is 140. 180 my triangle minus the 140 means this third one is 40 degrees. Looking at the 40 and the 60 here, 40 plus 60 is 100. 180 minus 100 means this angle is 80 degrees. So what's happening is these triangles have two pairs of angles that are congruent, but one of the triangles has been flipped around. It has been flipped over so that the 40 is at the top instead of the bottom. However, I still have two pairs of congruent angles. So yes, these are similar by angle-angle similarity. Example 6. We have one pair of congruent angles, and I'm going to compare the sides as ratios to see if they reduce to the same number. So I'm comparing 10 to 15. Ratio of 10 to 15. When I divide by 5, I get 2/3. Since I put the 10 on top, I'm going to keep the 6 on top. 6 to 9 divided by 3 also reduces to 2/3. It is the angle that's contained between the two sides. So these are similar by side angle side similarity. Number 7. There are actually two triangles here. We have the small top triangle that has this angle marked, and we have the large bottom triangle that has this angle marked. Now, I can't do anything with these angles on the right. I'm not sure if these lines are parallel. However, they both use this angle at the top. That angle is congruent to itself. So yes, these are similar by angle-angle similarity. We'll be working on page 493 to 495, numbers 9 through 25, 34, and 39 to 45.